So in this video, I'll be going over word problems involving linear equations. Okay, so hopefully this can be of help if you're studying for the SAT exam. All right, a lot of students have trouble with word problems because, first of all, they get intimidated by a bunch of words on the paper. And then secondly, they have trouble trying to translate these words into equations and expressions. Okay? So hopefully, if you're having trouble with that, maybe observing how I do it and mimicking how I do it can help you, can get the ball going to get you to be more competent in doing that. All right, so let's begin. Number 1, 2, 3, refer to this table over here, and this says manager of apartment building needs an electrician. Okay, I don't think this is important to read. So let's jump to this right away. So notice in the timed SAT test, a lot of the times these blurbs, you don't have to read the whole thing, or at all. Which the following equations gives the total cost Y of repairing the power generator in terms of the total number of hours X from company A. Okay, so let's look at what this table is. So there's two companies, okay? Company A looks like there's a fixed amount for a service call, and then there's an hourly rate as well. Okay, so maybe now we should skim this once now. Needs an electrician. Okay, the table below, the second sentence is more important. The table below shows the fixed amount for a time service call and hourly charges for two different companies, okay? So this is what I was expecting already as I was eyeing the table, looking at the table, peeking at the table, whatever the correct term is. So what is the question asking? Gives the total cost of repairing the power generator in terms of the total number of hours X from company A. So company A, well, there's a fixed amount for calling this company, $40. So no matter if they don't work at all, they just imagine you have them come to your house and then there's actually nothing wrong. Some companies actually charge you for them to come to your house. So that's the fixed $40. So even if they don't work at all, so when the hourly rate is zero, or the 0 hours, sorry, not hourly rate 0 hours, you'll still have to pay 40. So when X is 0, you still have to pay 40. Which one is that? That's choice D right away. And then we can also just confirm that, well, the hourly rate is 55. So for 1 hour, it's 55. For 2 hours, it's 2 times 55. You add it on to the fixed, 40. Okay? So hopefully you saw my thought process there. I just already thought, well, no hours, so you have to fix 40, which is only this one. For what number of hours X will the total cost of repairing the generator for company B be less than or equal to the total cost of repairing the generator for company A? So we got to set up an inequality, actually, not just equation, I guess, an inequality. So what's the total cost for company B? Well, it's the fixed 75. Okay, plus 48x, that's the hourly rate. Okay, will the total cost be less than or equal to, so follow that, translate that, less than or equal to the symbol. Total cost of repairing the generator for company A, so that's 40 plus 55x. Again, by this table, or we had that equation if we chose it correctly. Okay, so then we just solve for x over here. Okay, so that would be 35x is less than or equal to, so sorry, 35 is less than or equal to, minus 40 on both sides, and then minus 48, that's 7x. So x is greater than or equal to 5. So let's flip that, x is greater than or equal to 5, so that we easily see it's C. Okay. Company B's total cost, Y, is the fixed amount of, okay? If the relationship between company B's total cost, Y, and number of hours X is graphed in the XY plane, what does the slope of the line represent? This I can already tell without even looking at the choices. The slope is the hourly rate. That's choice B. How do I know that? Right away. Well, what's being changed per hour? That's what the slope is. What's the unit of the slope? Slope is rise over run, or change in y over change in x. What's change in y? The amount. Change in x is the number of hours. Okay? So by the units, you can already tell that it's going to be hourly rates. It's not a fixed amount because it's a slope, change in y over change in x. It's a rate. The change in x is divided by hours. So it's not a dollar amount. It's dollars per hour. Again, not an amount, not an amount. So you can eliminate A, C, D just by that as well. Okay. Apex Car Rental Company charges a flat fee of $40 per day plus 75 cents per mile to rent a car. Jason Car Rental for $64 per day, 60 cents per mile. If a car is rented for 3 days, at how many miles would the rental charges of the two companies be the same? Okay, so we got to set up equations again. So how do we do that here? Let's say the car is rented for 3 days. So for Apex, 3 days is $40 per day. That's $120. Okay, and then in addition to the cost per day, you have that variable of 75 cents miles, or 75 cents per mile. So it'll be 0.75x. Let's call the number of miles x. So you have to be able to denote what you're trying to find as a variable here. Okay. Similarly, for 3 days, for a flat fee of 64, what is that? That's 180 plus 12. That's 192, right? Plus 0.6x. Okay, so then we solve for x. 0.15x is 72. Okay, so x is 72 over 0.15. If we're not allowed a calculator, we have to be able to do this by hand. So 72 of 15 over 100. Sorry, that's not right. Divide by 0.15 is divide by 15 over 100. So that's 72 times 100 over 15. Now that's right over here. Okay, so I can divide by 3. That is 24. Okay, and then this would be 20. So this is 24 times 20, which is, what is that? That is 4AT. Answer is A. Okay, so again, as usual, the hard part for most people, I think, is setting up this equation. The math to do it, to find that x, was not hard afterward. Okay? It took Sarah a total of 42 minutes to jog from home to the park and back again by the same path. If she averaged 8 miles per hour going to the park and 6 miles per hour coming back, what is the distance from her home to her park? So notice I underline distance because that's what we're trying to find. So we got to use the formula distance equals rate times time, or the more general formula that I went over in previous video is like quantity equals rate times time. In this specific case, the quantity is a distance. Okay? So she took 42 minutes total to jog round trip to the park and back. Okay? It doesn't mean that she took was 21, right? It doesn't mean she took 21 minutes to go one way and 21 minutes back. No. In fact, it says that she averaged 8 miles per hour going, so she was faster going to the park, and she was slower going back because she was 6 miles per hour on average. So it's for sure not 21 minutes going and 21 back. It's a little more complicated than that. So how do we set this up? Well, you also got to be careful. 42 minutes, these are in miles per hour. So how many hours is this? This is 42 over 60, which is what? That is 7 over 10 hours. Or 0.7 hours, okay? So you got to be careful. You got to have the same units, okay? So we probably need to set up 2 equations here. That's what I'm thinking right now. How do we get those 2 equations? Well, she took 42 minutes total, so that's probably one equation. Let's say the time 1 plus time 2. You can say x and y. I like to just write time 1 time 2 and time 2. Time 1's going to the park, time 2's going back. So instead of x, y, I have to figure out which one's which, time 1, time 2. It makes more sense to me. Okay? Now, she averaged 8 miles per hour going to the park and 6 miles per hour coming back. So you got to think about it. From this formula, or actually, without even this formula, isn't the distance from going to the park and coming back from the park the same? So the rate that she went to the park, which is 8 miles per hour, so 8 times the time it took for her to go to the park, so T1. This is a distance, so now we're going to use this formula. This is a distance. This is the same distance as the distance she took, the distance it was to go back, which is, by this same formula, but a different rate now, 6 times T2. Okay, we can set this up because the distance, once again, going to the park and coming back from the park is the same. So this is equals rate times time. We know that the rate going to the park and the rate coming back is different. So of course, they will have a different time as well. And those two times should add up to 42. So here are our two equations. Now we can solve this system of equations. And it should not be 42, sorry. I don't know why I did that. This should be 0.7. That's why I did that up there. Okay? So now we solve this. Well, we can say that we can use substitution. T1 equals 6 over 8 T2. What's 6 over 8? That is 3/4, right? T2. So T1 is 3/4 of T2. So 3 over 4 T2 plus another T2 is 7 over 10. This is 7/10, right? Which we found up there. So this is how much over here? This is 7 over 4. T2 is 7 over 10. Okay, these 7s would cancel. And then we can multiply 4 on both sides. T2 is 4 over 10. Okay, therefore, T1 is, well, T1 plus T2 is 7/10. So T1 must be 3/10, even though we probably don't need that. What is the question asking? What's the distance from her home to her park? So we didn't need this at all. It was a waste of time. No, it was pretty fast, but it was a waste of time to find that. We need the distance, so we plug it into here. This was the distance, right? So 6 times 4 over 10. What is that? That's 24 over 10, which is 2.4 miles. Okay, so that's how I would think through this problem. Okay, setting up those equations, again, that's the hard part. Hopefully, as you observed me do it, you got a better sense of how to do it, and then, of course, you can mimic how I did it next time as well. Maybe in the next few problems, we'll see. Number 6, Carl drove from his home to the beach at an average speed of 50 miles per hour, returned home along the same route at an average speed of 30 miles per hour. His total driving time for the trip was 2 hours. Solving which of the following systems of equations yields X, the time it took for Carl to drive to the beach, Y, the time spent for the return trip. So this is just like the problem we just did. All right? So how can we set up the two equations here? The distance from home to the beach equals the distance from beach to the home. Again, distance equals rate times time. So the rate times the time, the rate to his speed to go from home to the beach was 50, and then the time it took was X, okay, equals 30 times Y. 50X equals 30Y. So we can already eliminate B and D. Okay, now how do we relate the X and Y? Well, total driving time for the trip was 2 hours. So it took him X hours to go to the beach, Y hours to return back. So the total, X plus Y, must be 2. Answer C. As simple as that. Okay. To join Ace Gym, one must pay $180 membership fee plus dues of $35 per month. Join Bash Gym, one must pay $300 membership fee plus $23 per month. At how many months would the cost of either gym be the same? So this is like the other problem we did with that company A, company B thing, right? So there's the fixed 180. That's like the initiation fee, what most gyms call it nowadays, plus 35 times the number of months, so 35x equals the second gym, 300 plus 23x. Okay? And then we just solve for x from here. So what is that? That is 12x is 120, x is 10. Answer is D. Okay? You can see how a lot of these problems are very similar. At County Fair, the admission is $8 and each ride costs $125. If you go to the fair with $20, what's the maximum number of rides you can go on? Okay, so you got to be careful for this one probably because of rounding, especially the numbers are so close. So you got to round properly. And you only round at the very end. Otherwise, you'll have rounding error in between. So you have the fixed $8 and then you have 125x. Okay, that must be less than or equal to 20. Okay, $8 and $125 per ride, you only have a maximum of $20. So 1.25x, so 5 over 4x, less than or equal to 12. So 5x less than or equal to 48. Okay, x is less than or equal to 48 over 5. So it looks like it's less than 10 rides for sure, right? Because 50 over 5 is 10, so eliminate CD. Do we get 9 rides? We do, because 9 times 5 is 45. And then we have $3 extra, it looks like. Or $5 extra. It's not $5. What am I saying right now? It should be 9 though. Let me double check that's correct so far. First of all, yeah, 9 rides. Yeah, that's fine here. We didn't have $50. That's what I was confused about. We started with 20. This is a fraction now. Okay. A car averages 18 miles per gallon for city driving, 27 miles per gallon for highway driving. What's the total number of gallons of gas needed to drive 6x miles in the city and 18x miles on the highway? Okay, so number of gallons, so quantity equals rate times time type of thing. So the rate is 18 miles per gallon. Okay, miles per gallon. Let me even write the units out. Okay, times 18 miles per gallon. Okay, and then the total number of gallons of gas needed to drive 6x miles in the city and 18x miles on the highway. So times some number of gallons equals 6x miles. Times some amount of gallons, right? And similarly, excuse me, sorry about that. I lost my train of thought now. 18x miles is 27 miles per gallon times some number of gallons. Okay? So we want this number of gallons plus this number of gallons. Okay, so we can solve for these. So that is 6x. You can see the units work out, right? Gallons per mile. So 6x over 18 plus 18x over 27 is the number of gallons we want. Okay, so that is, here you gotta, let's simplify this in 1/3, right? Yep, and this is 2/3. So this is just 1x gallon or just x gallons. Okay, so answer is A. Again, see, the units helps me out here. So I would recommend use the units if that can help you at least set up the problem. Okay, last one. One section of a grocery store display only water bottles. Okay, the water bottles are either in 6-bottle packages or 8-bottle packages. Let X represent the number of 6-bottle packages and Y represent the number of 8-bottle packages. Total number of packages displayed are 270. Total number of bottles are 1860. To find the value of variables X and Y, which the following system of equations can be used. Okay, so there's 270 packages. There's X 6-bottle packages and Y 8 bottle packages. So x plus y should be 270. Cross this one out. Cross this one out. We're left with B and C. Okay? Now, how many bottles are there total? There's 6 bottles for each of the X packages. So 6X plus 8Y equals 1860. So that's B. Okay? And that's it for this additional problem set. Again, hopefully this was good practice for you, especially if you are struggling with word problems. And hopefully you observed how I thought through the problems. Maybe you can take some insight from that and maybe mimic how I do it too. Especially like, for example, the units in this one. That helps me out, honestly. And things like that. All right? Otherwise, you saw how similar some of these problems were, actually. They can only really change so many times at this level. So you should study these carefully if you were stuck on some of them. All right? As always, please like and subscribe if you found this helpful.